Hello friends, welcome back to BitSize Python. My name is Nijat. Hope you're having fun solving some LeetCode questions. If you haven't already, please subscribe to this channel so that we can work on more LeetCode questions together in this channel. Today we're going to work on LeetCode question number 4, the median of the two sorted arrays. So the given problem is that we're given two sorted arrays, num1 and num2 of size m and n respectively, and we need to find the median of the two sorted arrays. For example, num1 is 1, 3, num2 is 2, and then the output is 2 because when we combine these two arrays, 1, 2, 3, the median is 2. The second example is num1 is 1, 2, num2 is 3, 4, and then the median of this combined array is 2.5. The constraints here, the recommended data structure for this problem is, data structure and algorithm for this problem is binary search on a smaller of the two arrays, so that we can actually reduce the time complexity to log of min of mn. So I have given you the step-by-step logic to solve this problem here. However, let's just focus on how to write this function step-by-step here. So the name of this function is find median sorted arrays. So we've given A and then B two arrays. For example, A could be 1, 3, 5 and B is 2, 4, 6. So step one is ensure that we work with the shorter arrays. In order to do this, we will write an if statement. If len A greater than len B. In this case, we're going to swap A and B. So this basically means that if A is longer array, we're going to make A B and then B A. So that makes sure that we are only working with the smaller arrays. And step two is we're defining the length of the two arrays. We're creating two variables, len A and len B. Len A and len B is len A and len B. So this step is easy. We're just creating two variables and giving the length of the two arrays here. Step 3 is initialize the binary search pointers, low and high. This step is also easy. We're just creating two variables, low and high, and giving the for the low, it's going to be 0 because we're focusing on the array A, so that's the zeroth item, and then the largest high one is the total length of A. So that's the search space. So 0th index all the way to the length, total length of A. Okay, so step 4 is perform binary search to find the correct partition. In order to do that, we will use a while loop. While low is smaller than or equal to high. So this is a conventional binary search condition. And then while this condition is true, we're going to create two variables, split A and split B for array A and array B. Split A is the midpoint of A and split B is the midpoint of B. So let's write that. Split A is equal to low plus high integer division by 2. So this is basically the midpoint of A. For example, in our example, we've given 1, 3, 5. The split A is equal to, low is 0, high is 2. If we calculate that, it's going to give us 1. So that basically means that at index, we're going to partition this at index 1, and we're going to give this divider right in front of 3, and it means that we have one element on the left side of this divider. So, and then split B is a bit different. We're going to use len A plus len B plus 1, integer division by 2 minus split A. This basically means that we're adding the elements on the both A and then B. This is the total elements, and divided by 2. This is basically the total midpoint minus the midpoint of A is going to give us the midpoint of B. So split B is totally dependent on split B. So let's just quickly calculate for our example B. So B is going to give us is 2, 4, 6. And then split B is equal to let's say 3 plus 3 plus 1, 7, integer division by 2 is 3, 3 minus split A, which is 1, is equal to 2. So that basically means that at index 2, we're going to give it a divider. On the left side, we have 2 elements. So we have done with split A and split B. The values are given here. And then now we're ready to handle some edge cases. So in order to understand that, I've given you this A and then B, and then where things are at. So here's 3, so we've divided it here, right in front of 3, and then right in front of 6. So split A, this value is 3, because 3 is sitting at index 1, and then 6 here is sitting at index 2. Okay, so in order to handle some edge cases, we will create 4 variables. The variables are called max left A, and then min right A, and then max left B, and then min right B. So on the left hand side, so the max left A basically means that it's the maximum value on the left hand side of the split. So the min right A basically means it's the minimum or the smallest element on the right hand side of the split. The same thing goes with B, so I'm not going to explain that here. So let's just quickly write max left A. So max left A is equal to, let's just write the code first and I'll explain. So it basically means that if the split A is 0, so if the index of the split A pointing, this thing is pointing to 0, it basically means that there's nothing on the left hand side of the array, so we're going to give it negative infinity. Otherwise, this maximum left A is going to point at split A minus 1. The same thing goes with min right A. So again, this is the same as here, but it's on the other extreme. If split A is equal to len A, if split A is equal to the largest element in this array, then we don't have anything on the right hand side, so it's going to be, the value is going to be positive infinity. Otherwise, we're just going to give this split A value to it. So that is max left A and then min right A. And then this exact same thing for B. So I'm just going to copy this and then just change all of the A's into B's. This A is also B, 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 and B. So all we're trying to do is we created these variables just before and then after this divider for each array. So we called the maximum left A is pointing towards the maximum element on the left hand side, while the minimum min right A, min right B is pointing on the smallest element on the right hand side. So now we're ready for step 5. Step 5 is basically using what we've just created right now, these max min values, to check if the partition is correct. So in order to check if we have found the correct partition, we're going to make sure that this total left is smaller than or equal to this total right. In order to do that, what we can do is we can do this crisscross pattern. We can check if max left A is smaller than equal to min right B, and then max left B is smaller than equal to min right A, and then both has to be true at the same time. We can just write this as if max left A smaller than or equal to min right B, and max left B smaller than equal to min right A. So basically, this condition, when this two conditions are met, we are making sure that the total left-hand side is smaller than or equal to the total right-hand side. If that's the case, we have a perfect partition or split. And then within that, we need to make sure that the total length is actually even or odd. In the even case, if the total length is even, we can find the median value by averaging the two middle values. So if len A plus len B modulo 2 equal to 0, if that's the case, we have an even length. If that's the case, we're going to return maximum of max left A, max left B. So we're going to choose in whichever one is the highest in the two arrays, plus minimum of min right A or min right B. So we're going to choose the minimum on the right hand side and then maximum on the left hand side, and then sum them and then divide by 2. This effectively gives us the average of the two middle values. So this is in the even case scenario. What if it's odd? If it's odd, we're going to do an else statement. We're going to return just the max of max left A or max left B. In the odd case scenario, we're just going to choose on the left hand side whichever one is the largest. That's going to be the median. This is possible because earlier we have put this plus 1. This plus 1 is going to take care of this odd case scenario, and then always put that medium value on the left hand side. Okay, so we're done with step 5. We've checked the perfect case scenario here. However, what if the partition is not perfect? If it's smaller or is larger? There are two conditions. If, so the first one is the opposite of this condition. If the opposite is greater than. What if the max left A is too big? It means that the split A is far to the right. So how do we adjust this? In order to adjust that, we're going to just move the high pointer. We're going to reduce that by split A minus 1. Because min left A is too large, it means that it's the divider is way to the right, so we will just reduce and move it to the left. In order to do that, we will just minus 1 from split A, and it's going to adjust high. And then what if the other case's opposite is true? So, for example, this one. The last case is basically max left B is greater than min right A. What if that's the case? We're going to, if that's the case, then split A is far to the left. So we have to move the low pointer by adding 1 to the split A. So this makes sure that if max left A is way too big, that means that the divider is way to the left, and then to adjust the low, we can just adjust the low pointer by adding 1 to the split A, and then this will adjust the binary search region. So now we're done. Let's just quickly summarize what we've done so far. So first, we made sure that we're only working on the smaller array to optimize the binary search. Second, we are calculating the length of each array and then initializing len A and len B. And then in step 3, we have initialized the binary search boundaries, which is the boundary of A, which is 0, and len A. And in step 4, we got into the loop, in the binary search loop, and then we split A and then B, and then we handled some of the edge cases, especially when split A is 0 and then its length, and split B is 0 or its length. And then after that, we've looked at 3 conditions. The first condition is the perfect condition, and then within the perfect condition, we looked at if the total length is even, and then if the total length is odd. Lastly, if the condition is not perfect, if it's the opposite, we looked at those cases one by one. If this case, then we've adjusted the high pointer. If the other case, then we adjusted the low pointer. So that's the total function that we've written. Let's just quickly run it. And then we also have this example of A is 135 and B is 246. And then now let's just quickly run if our function is working correctly. So we run it and it gave us the correct answer. So the median of this combined array is 3.5. So let's just quickly summarize. We used binary search on a smaller array to identify the balanced split or partition across both arrays. And then this gives us a time complexity of log of min of mn. That's it for today. Thank you for watching today's video, and then see you in next video when I tackle LeetCode question number 5.